Now that we know how to convert from logarithms to exponentials and vice versa, we can talk about how we can solve certain variables, or excuse me, solve certain logarithms is what I should have said. For example, log base 2 of 16, this equation on top, log base 2 of 16. We want to rewrite this as an exponential because log base 2 of 16 doesn't really make sense to us. It's pretty difficult to do that in your head. But we know we're trying to figure out what this equals. So I'm just going to say it equals x because we don't know what it equals. We're looking for what it equals, so we're looking for x. If we just apply what we just learned about converting from logs to exponentials, where we put our base here, our power here, and our answer here, then it becomes a lot simpler. We can just say, okay, well 2 raised to what power equals 16? And that should hopefully make more sense to you than log base 2 of 16. If you need to guess and check this in your calculator, you can, but you're going to find that x is equal to 4. 2 raised to the 4th power gives you 16. Same thing on this next example, log base 3 of 9. We're going to say it's equal to x because we're trying to figure out what it equals. So we get 3 raised to the x equals 9. Hopefully that's a simple enough one you can just look at it and tell. 3 raised to what power gives you 9? That would be 2. 3 squared gives you 9. So same process on this last example. Log of 25, base 25 of 5 equals x. So 25 raised to the x equals 5. Okay, so you have to be a little more sly on this one. Think about it a little more carefully. 25 raised to what power equals x? Okay, well, think about how you get from 25 to 5. You don't square it or cube it, you actually square root it. So the square root of 25 equals 5. And if you remember, a square root is the same as a power of 1/2. So 25 raised to the 1/2 gives you 5, gives you square root. So remember, square root is the same as 1/2, cube root is the same as 1/3, and so on. Okay, there are two particular types you should look out for when you're evaluating. One is when the base and what you're looking for have the same number. So for example, log base 7 of 7. Well, let's do this one. So if we set it equal to x, we get 7 raised to the x equals 7. Well, clearly x would have to be equal to 1 because 7 raised to the first just gives you the same thing. Okay, let's say we did log of 15 log base 15 of 15 equals x. Again, you'd get 15 raised to the x equals 15, so x would have to be 1. It turns out, anytime those two numbers match, your answer is always 1. And hopefully it's clear when you look and convert it over to a exponential why that would be. Also, there's something that's going to happen anytime what you're taking the log of is 1. So let's say log base 5 of 1. Well, if we set that equal to x, since we're trying to find it, we would get 5 raised to the x equals 1. So you have to remember, what power reduces everything to a 1? Well, that would be 0. Okay, and that's going to be true no matter what your base is. If you're doing it of 1, you're going to end up getting 0. So another property you can look out for is that log base a of 1 is always going to be equal to 0. Now, if you can't remember these two properties, that's okay. You can always just convert these things to exponentials like we have been, excuse me, and still get the same answer. But this will save you a little bit of time if you can commit those to memory. The last thing we want to do is look at the inverse properties of log. So for example, I'm just going to show you some examples first because I think it'll become pretty clear pretty quickly. Let's say they ask you to evaluate log base 4 of 4 cubed. Well, it turns out that that's just going to be 3. Anytime these two numbers match, this is all that's going to be left over. So if you had log base 11 of 11 cubed, that would also be 3. Doesn't matter that I used 3 twice, that was just coincidence. So the rule here, the property, is that log base a of a raised to the x power is always going to be x, whatever that is. And if you think about converting this to an exponential, that should make sense. You've got your base and your power, so a to the x equals answer a to the x. So that's why those things work out that way. So that's the property right here. Log base a of a raised to the x will just give you that exponent. You can also go the opposite way. Let's say we have 6 raised to log base 6 of 4. Well, since this 6 and this 6 match, it's just going to turn out to be 4. Or if we have 9 raised to the log base 9 of 11, then our answer will just be 11. Because if these two match, then they're just going to cancel each other out, and you'll just be left with 11. So the rule for this one is that if you have a raised to log base a of x, your answer will just be x. And that completes the notes for today. If you haven't already done it, the homework for this section is page 395 to 397, 2 through 38 even, 62 to 66 even, and then 81 to 84 all.